we will continue with the next classification, that is Mendeleev's periodic table. The scientist name is Dmitry Ivanovich Mendeleev. Dmitry Ivanovich Mendeleev. At the time Mendeleev started his work, 63 elements were known. Totally 63 elements were known at that time. He reacted every element with hydrogen and oxygen. He took hydrogen and oxygen because they are highly reactive and they form compounds with almost all the elements. And after reaction, he take 63 cards and write the properties of all the elements. Then he come to know that some of the elements shows similar properties. Then he grouped those elements together and he stated his law. For example, he grouped lithium and sodium together because this lithium and sodium reacts with hydrogen to form their hydrides. That is, lithium react with hydrogen to form lithium hydride and sodium react with hydrogen to form sodium hydride, and oxygen to they react with oxygen to form lithium oxide and sodium oxide, and they react with water to form their hydroxides. And by doing this, he arranged the elements in the increasing order of their atomic masses. Then he stated his law, that is, the physical and chemical properties are the periodic functions of their atomic masses. That statement states that the physical and chemical properties are the periodic functions of their atomic masses. This is the statement of Mendeleev's periodic table. That is, the physical and chemical properties are the periodic functions of their atomic masses because he arranged the elements in the increasing order of their atomic masses. Now, we will discuss some of the achievements of this Mendeleev's periodic table. The first achievement is, in Mendeleev's periodic table, vertical columns are called as groups and horizontal rows are called as periods. This is the first achievement. Vertical columns are called as groups and horizontal rows are called as periods. And the second main achievement of this Mendeleev's periodic table is, he left the gap for the elements which were not discovered yet. This is the beauty of the Mendeleev's periodic table. He left the gap for the elements which were not discovered yet. He predicted that some more elements would be discovered in future and he left the gap for those elements, and he predicted the properties of those elements, and he also gave the name for those elements. That is, he named Eka aluminium, Eka boron, and other one is Eka silicon. Eka silicon. Here he predicted the properties of these elements, that is Eka aluminium, Eka boron and Eka silicon. In nowadays, this Eka aluminium is called as gallium and Eka boron is called as scandium, and also the Eka silicon is called as germanium. This is the beauty of the Mendeleev's periodic table because he predicted some more elements would be discovered in future. And here Eka aluminium is called, it is important, Eka aluminium is called as gallium, Eka boron is called as scandium and Eka silicon is called as germanium. The next achievement is placement of heavier elements before lighter elements. Mendeleev arranged the elements in the increasing order of their atomic masses because he wanted to group the elements with the similar properties. Here, in some cases, he placed heavier elements first and then lighter elements. That is, high atomic mass element first, then low atomic mass element. For example, he placed cobalt. Cobalt is having the atomic mass 58.93 and nickel is having the atomic mass 58.71. He placed cobalt first even though it is having high atomic mass, then nickel. He done this because He wanted to group the element with the similar properties. Here cobalt is having similar properties as that of lower elements, that is rhodium and iridium. Similarly, platinum is having similar properties with platinum and palladium. And other example for this is tellurium and iodine. Tellurium is having the atomic mass 127.6 and iodine is having atomic mass 126.5. Tellurium is placed first even though it is having the high atomic mass. And the last achievement is about the placement of noble gases. Noble gases are discovered very late because of their inertness and low concentration in the atmosphere. Once they were discovered, they grouped separately and they were placed without disturbing the periodic table, that is Mendeleev's periodic table. These are the achievements of Mendeleev's periodic table. Now, we will discuss some of the limitations of this Mendeleev's periodic table. The first limitation is about the place for hydrogen. That is, no fixed place for hydrogen. In Mendeleev's periodic table, he placed hydrogen in group 1, that is with alkali metals. It shows similar properties as that of alkali metals, that is, like alkali metals, it combines with halogen, sulfur and oxygen and form the compounds. And other thing is, hydrogen also shows similar properties as that of halogens. That is, it combined with metals and non-metals to form covalent compound. Therefore, it is not possible to place hydrogen whether in group 1 or group 7. It is the limitation, that is, it did not give the perfect place for hydrogen. This is the first limitation. And the second limitation is about isotopes. Isotopes means these are the compounds which are having similar chemical properties but different atomic masses. The limitation is he did not give the perfect place for isotopes because they were discovered very late. This is the second limitation. And the last limitation is about the number of elements between two elements. Here he arranged the elements in the increasing order of their atomic masses. But the atomic mass did not increase regularly. Therefore, it is not possible to predict how many elements were present between two elements. This is the third limitation. These are the limitations of Mendeleev's periodic table.